Hello everyone, I'm going to try something new for my revision for my WACE exams. Obviously I'm year 12 right now. I am currently doing methods, physics, spec, chemistry and English. And part of my revision strategy is to just do a bunch of exams. So I'm going to be recording myself doing these WACE exams. I haven't done this before. Usually I just do them by myself on paper. But I thought it might be good to try and record myself teaching you how I go through these. And I'm not 99.95, I'm pretty high though, so 99.55, so I do make quite a few mistakes here and there. Hopefully at the end though, we will go look at what those mistakes are, because what I'm thinking is that I record myself doing the exam, the full 100 minutes or 3 hours, whatever exam I'm doing right now, and then at the end I will mark it off camera, and then I'll cut, and I'll discuss the errors I made throughout the exam. I've already done the calculator free for this 2016 WACE exam, this for methods, so I'll just be going on for calculator soon. I had the idea like halfway through me doing the calc free section. So yeah, here we go. 1 hour and 40 minutes. Oh yeah, I won't be doing the 10 minutes of reading time because like, I don't know, I don't care. It's not really that good for math exams. I guess you can kind of think through your process for the first few questions, but I don't know, it doesn't make a difference for me. Anyway, there we go. 100 minutes. First question. Exponential. We have a half-life, which means that half of it is going to disappear. 105 days. So, this is essentially saying that half of PO is going to happen when I'm going to sub in 100.5 for T. Okay. And then obviously these are going to cancel, so then half is equal to E 100.5k. And if I look at this on a CAS, I'm just going to be solving it like this. Oh yeah, you guys won't be able to see what I do on the CAS, which is a bit unfortunate, but I'll try to make it obvious as I can. E 100.5x. On a CAS, I get that k is equal to negative 0.006897. Okay, I'm back. I already got interrupted, but it's fine. We're gonna continue from where we were. Where were we? So we found the value for k. Is that it? Okay, yes. Oh wait, it wants 3 significant figures. So I'll just change this to 90. Yeah. How many days will it take for 100 grams of substance to first decay below 5 grams? So we got a new initial value. So we're gonna get 500 is equal to 5 is equal to 100 E. We're going to use that value of K. What's it? 90, I think. And then we want to find T. So again on CAS, we just solve this. E 0.0690x. Now you get that T is equal to 434.2 days. Because I'm pretty sure that's what we're working in. Days and grams. Okay. Determine the rate of change of the amount of Fermi on the day found in part B. So I know that dm over dt is just going to be equal to k, which is negative 0.0069 m. That's because when I differentiate p with respect to t, I'm just gonna, not the t, that k is just gonna come out to the front, and then I'm gonna have p. Actually, they call it p, so I'm gonna write big letter p here instead of m. Then I know, again, on the day found in part B. So at p, and t is 345.2, that's just equal to 5. So then dp dt is equal to negative 0.0069 times 5. Putting it in my CAS, even though I can probably work that out in my head, but I just want to stay humble and acknowledge that I probably make a lot more mistakes than the CAS does. So I'm just going to put that in my CAS, 0. And then this would be grams a day. I've noticed that WACE likes when we write statements about what this actually means, so I'm just going to write here decreasing at 0.0345 grams per day. Alright, seems reasonable. Survey in Western Australia. So I have 1,400, 986, confidence interval, 3 decimal places, what assumption was made calculating this interval? Okay, what assumption was made? Well, since 1,450 is greater than 30, then assume normal distribution. Then I can figure my p hat, which is 986 over 1450, which is going to be equal to 986 divided by 1450. I'm probably going to do this to 4 decimal places. Oh, never mind. 0.68 exactly. Now I want a 90% confidence interval. So then, for 90% confidence, K is equal to 1.645. Therefore, my margin of error is going to be equal to 1.645 square root of 0.68, 0.32, yep, 1450. Let me just make this square root a little bit longer so they can see it's all within there. To the calculator I go. I'm just gonna plug that straight in. 68 times 0.2. 1450, and this gives me 0.02015. Therefore, my interval, the mean is gonna be my p hat. Then I'm just gonna take away, and it's at like some 3 decimal places. Okay, so then 0.660. So minus the upper bound is gonna be 0.770. The margin of oh, they probably wanted me to just do that on cash calculator. Yeah, it was only 3 marks, right enough. Okay, how many marks is this? 2 marks. 2 marks. I can just write the answer and get full marks. So there you go. Just already found that. Another 3 surveys were conducted. This time the surveys are more likely to be taken outside of Western Australia. Now, this survey was taken inside of Western Australia. Yep. So let's find p hat for each of these surveys. So for 2, p hat is equal to 1772 over 3221. 1772. 0.5501 for 3. I'm not gonna write the fraction for all of these. I'm just gonna put them in my calculator. 1021 divided by 1566. 6520. So I'm going to do these to 4 because it's like the statistics probability section, and they always like it to 4 decimal places. And then for 4, p hat is equal to 0.6839. Now, my confidence interval is 6 to 7. So only 4 is inside of that. So survey 2 and 3 have p hat outside 90% confidence interval for p, therefore likely be taken outside of, oh, that is terrible, of WA. Using the sample proportions, determine the sample size or half the margin of error for the proportion. Let's have confidence of 90%. Okay, my sample proportion was 0.68. My margin of error was 0.02015. Therefore, my half margin of error is going to be 0. Put this in the calculator, 0.01075. Then again, for 90% confidence, K is equal to 1.645. Then I have enough information, so I can just put this into my equation. 645 squared square root of 0.68, 0.32. Okay, let me just make sure that's the correct 0.32. Yeah, that is correct. And then here I'm just gonna write cast n is equal to 1075 is equal to x45 0.68 0.32 times x, square root all of that. I get n is equal to 5800.97. Obviously can't have 0.97 of a person, so I'm gonna write at least, or therefore at least 5801. Triangle we found at the formula area equals AB sine C's. Range of equilateral triangle each side of 10 centimeters. Okay, so we know it's equilateral. So we know that all of these are gonna be the same, 60 degrees of pi on 3. So C is gonna be, I'm just gonna write C is equal to pi on 3 radians. That was a terrible 3. Okay, and then since all the sides are equal, A and B are gonna be equal, the area is equal to x squared onto sine of pi on 3. X squared on 2 sine of pi on 3 is going to be square root of 3 and 2. Okay. Now, it wants me to use the increment formula. Actually, I'll tie this up a little bit. X squared square root of 3 on 4. Okay. Increments formula. So I know that small change, small change in A is approximately equal to dA dx times a small change in x. Now I know that dA dx is going to be equal to, it's pretty easy, x square root of 3 on 2, because I moved that 2 in front. Yep. So then bring an arrow, bring it up here. S of A is approximately equal to, now 10 centimeters, so this is going to be 10 square root of 3 on 2, and an increase of 0.1, so I'm just going to write that as 1/10. Okay, so then these 10s cancel, it's just going to be approximately equal to square root of 3 on 2, which is approximately 0.866 centimeters squared. Okay. Let me just check this on the calculator. Just check these values. 10 pi divided by 3 times 0.1. Everything looks correct. Sine of pi on 3. Yeah, it looks so good. Okay, next question. A Richter scale. So logarithms 5.5. 3.4. Oh, I'm already tired, Jesus. Okay. So I'm gonna say that 5.5 is going to be equal to log 10. I'm going to call this A of NZ, AO. And then, what is it, 3.4? Same scale, yep. So log 10 A. I'm going to say that for Hayman Islands, just a H. Oh, I hate how my pen squeaks because like my palm's getting sweaty. Okay, I'm back. I got interrupted. I think the time was 1:20:12 when I got interrupted, but it's all good now. So I'm gonna start my recordings again. Let me get that markup up. Markup. Start recording. I'll start the timer now. Okay, we'll continue. Where were we? Let's see. I think we were here. Okay. And we wanted to find how many times larger is the magnitude of the waves in New Zealand compared to those at Hayman Island. So I want to find, let's write it over here, A and Z over AH. Now, I'm going to get that. I think if I take these equations away from each other, so if I call that 1 and I call that 2, then when I take these away, I'm going to get a log minus a log, which would be a division. And yeah, okay. I think that's where we want to go. So 5.5 minus 2.4, 2.1 is going to be equal to log 10 and z over AO minus log 10 of AH over AO. And then so 2.1 log 10 ANZ over AO. So when I get this minus here, I'm gonna divide it. I'm gonna divide by AH over AO. When I divide by fraction, I want to flip the fraction and multiply. So something like that. These AOs will cancel. So 2.1 is equal to log 10 ANZ over AO. And then I can just put everything exponent of a base of 10. So A and Z over AO. I'm going to put down a calculator. And Z over AO. 10 to the power of 2.1. 125.89. Oh god. 89. Waves at New Zealand were approximately 126 times more intense. More intense? Amplitude. Oh, it's amplitude. How am I gonna rewrite this? Amplitude of waves. Alright, so I'm just writing larger here. And write amp of waves. Okay. That's all good. Determine d dx x squared ln x. Okay, product rule. So the first bit is going to be 2x times that by ln of x. The next bit is going to be 1 over x times x squared. So this gets 2x ln of x plus x. Using your answer from part A, show that the graph of that has only one stationary point. So I'm going to write if stationary point, then d dx must be equal to 0. Therefore 0 must be equal to 2x ln of x plus 1. Sorry, not plus 1, I'm skipping a step. X outside of, so I can factor that out, ln of x plus 1. Therefore x equals 0, or 2 ln of x plus 1 equals 0. So then ln of x is equal to negative 1 or 2. And this has no solutions because ln of x cannot become a negative. It has to be positive. So there's no solutions for that value. Now I have to sketch a graph of yx squared ln of x. I'm just gonna bring this up on CAS. 3 marks. X squared ln of x. I'm gonna fit my scale. I'm gonna put my y minus negative 1.1, 5.1. What is that, like negative 1, and then make that 11. Okay. I just like setting my scale and my CAS graph the same as it looks on the graph that they give us, just so it's really easy. Okay, let me find roots. That doesn't look like a stationary point at x equals 0. I might have done something wrong. We'll see. So, one root there. Is that the only root? Looks like it. Okay. Minimum point. Yeah, that does not look like. Did I do something wrong? Oh no, wait. This. I'm a bit confused now. Hold on. Oh, I see. No, I was wrong. X equals. But this x equals 0 is wrong because you cannot put 0 into ln of x. So I'm gonna write this. Okay, let's figure out what this is. So this is just going to be x is equal to e negative 1 on 2. And I'm right here disregard as x must be greater than 0 for x squared ln of x. There we go. So then now I can do this. So then there's a minimum point at like 0.6. Okay, what's the scale on this? This is 0.4? 8, 1.2, 1.6. Yeah, okay, that's a bit of an odd scale. And then this is 0.2. So yeah. So here 0.6 negative, that's a minimum. So I'll just label this 0.606. This will be tough to label. Negative 0.1843 decimal places should be enough. And then when x is approaching 0, this will equal 0. So I'm just going to draw something like that. And then I'm going to put in some values here. So x, I'm going to do a y calc when x is equal to 2. And x is equal to 2. Y is 2.7. So about there. And then let's do like 4. 22. Okay, that's already out. What about 3? I don't want to be my graphs as accurate as possible, especially since I'm on the calculator section. 9.8. So that's like up here. Okay. Now I'm gonna connect these dots. Oh god. Let me redraw this. Something like that. A bit more curvy. Because half the time you get a mark just for having a straight curve. Draw a little arrow like that. That's the minimum. This is 1, 0. It doesn't actually reach 0, 0, so I'm going to leave that. Unmarked. Calculate the area bounded by the graph. The x-axis, x equals 1 and x equals e. So x equals e is greater than x equals 1, and it's going to be all above the x-axis. So all I got to do is going to write area is equal to 1 to e of x squared ln of x dx. Just plug it in my calculator. I should really set a keybind for the integral sign. Haven't got around to doing it yet. I actually don't know what I would put it as anyway. I get that the area here is 5.74. I'll do 4 decimal places, and I don't think we were given units, so I'm just going to write units squared. Yeah. Okay, next question. A simulation loaded and recorded with the following results. Calculate proportion of prime numbers recorded in this simulation. Prime numbers would be 2, 3, and 5. So that's 15, 30, and 35. So p hat is equal to 35 over 60. Let's make sure. So I should get 25 for 4 and 1. That's correct. It's 2 marks. It's probably fine like that, but I'm just gonna put that as a decimal just in case. Determine the mean and standard deviation for the sample portion of using the results above. Sample proportion. Okay. So this is gonna be something like, it wants the proportion, so it's gonna be normal. So then the mean is gonna be just the p. So I'll do the fraction version. That's 7 over 12. And then standard deviation is gonna be 7 over 12 times 5 over 12 all over, I think it was 60. Yeah, it was definitely 60. So let's put this in my calculator. 7 over 12 times 5 over 12 times 60. And I get 0.0636. And put this up here. just write the value again. 0.583. Sometimes I have troubles writing 3, so I'm not sure why. Okay, page. Okay, looks like there's 24 pages, but how many pages are actually of work? 19 pages. So we're nearly halfway through the exam already. And we are cooking on time. It's only been, what, 30 minutes? Let's go. It's been decided to create a confidence interval for a proportion of prime numbers using a simulation to page 8. The confidence. The smallest margin of error. Explain which level of confidence will give the smallest margin of error. As confidence increases, then my K value increases. As MOE is equal to K of theta, and actually I want to write as again. I'll just put a little comma here. When confidence MOE increases, therefore for smallest margin of error, 90% confidence. God, I hate this squeaking. I already said it. Jesus. I'm gonna reword this. I'm just gonna say therefore 90% confidence will have lowest I'll say smallest. I'll put an arrow. Smallest margin of error. God, bro. Okay, I'm actually so sick of this pen squeaking. I think it's just because my hand gets really sweaty. But yeah, there we go. Have the smallest margin of error. Now I have to state what the margin of error is. K is equal to 1.645 for 90% confidence. Therefore, the margin of error is going to be equal to 1.645. And then I already calculated my standard deviation, which is going to be 0.0636. Oh god, that is not a 3. 6. Put that in a calculator. I get that this is going to be equal to 1046. Alright, the simulation of 60 rolls is performed another 200 times with a proportion of 100. Comment briefly on the features of this graph. What do you mean by features? Roughly symmetrical? Okay, so let me think about this graph. This is the normal distribution graph. It's just symmetrical. Oh, okay. So, yeah. So I'm going to say roughly symmetrical, and I think the other one's probably going to be like peak at. Roughly symmetrical around peak at p hat equals, what was the mean again? 0.5833. Is that gonna be, I think that'll be, yeah, that should be 2 marks. One for symmetrical, the other for around the peak. I can't think of anything else really. I guess I can write here like a norm distribution. Maybe that might be a mark, I'm not sure. Normal distribution graph. I don't know, between those 3, hopefully that will net me all 2 marks. Okay, officially passed halfway of the exam, and we've only been working for 25 minutes. Look at us go. Okay, I told you guys that tetrahedral dice set numbers 1 to 4. Copy side is like equal likelihood face down. And throw twice. Sum of 2 rows is 1. What am I looking at? We're just like, oh, okay. This is literally just me filling this out. I thought this was like, I thought this was the probability table, and I was extra confused for a second. Okay. I believe that's all it wants me to do. So I'm just gonna 7, 6, 7, and 8. Okay, that should be it. Yeah, I think that's what it wants me to do. So here I have 3 of 3s, 3 16s. 4, I have 4. I'm gonna leave it as 4 and 16, just so then everything has the same denominator and I'm not confused. I have 4 again. 1, 2, 3, 4. 3, and then 2. Does that add up? 1 plus 3 is 4. That's 12, 15, 18. Nice. Calculate the probability of obtaining a sum of 5 or less. Well, it's 5 or less, then I just have to add up these. I just add up from here onwards, so that's 4 plus 4 plus 3, that's going to be 12 on 16. So probability of x is less than or equal 5. It's going to be 4 plus 4 plus 3 plus 1 all over 16. That gives me 12 on 16. And simplify that to 3 on 4. Determine the mean and standard deviation for x. Here comes the stats calculator. Okay, here we go. So I just wanted the stats mode. In list 1, I'm putting 2, 3, 4, 5, 6, 7, 8. And then in list 2, I'm putting the probabilities. So 1 divided by 16, 3 divided by 16, 4 divided by 16, 4 divided by 16, 3 divided by 16, 2 divided by 16, 1 divided by 16. For 7, I accidentally did something weird. Okay, there you go. Wait. Ah, no wonder. I wrote 18 here. Should be 16. Okay. 2 divided by 16. Those are up to 16. 12. This doesn't have to 16, does it? 12, 15, 17, 18. What have I done wrong here? 3, 4. 3, 4. Oh, wait, I accidentally counted this row when I was counting. Okay. So this would be 2 and 3 here. Yeah, that makes sense because they should be symmetrical. There we go. 4. Sorry, so this is 6. 4, 6. Okay, there we go. That's correct now. Okay, now I have to fix that in my list. I was thinking it was a bit weird. 116. 3 divided by 16, 4 divided by 16, 3 divided by 16, 2 divided by 16, 1 divided by 16. Okay, now I go calculate this two-way variable frequency. I change to list 2. The mean is going to be equal to 5. Standard deviation is 1.5811. And I'll just write here that I got it from CAS stats table. Okay, there you go. Page 11. An automated milk bottling machine fills the bottles uniformly to between blah blah blah. Hit a hole. Multiply the contains less than the labeled amount. Okay. So if I'm gonna have, let's do a rough sketch. Now to get between 247 and 255. So then I don't know how to explain this. So then there's 8 milliliters difference there. So then this value here is 1/8, something like this. And then we go from 247 to 255. Contains less than the labeled amount. Labeled amount, let's just say like this is like X. and this is mini x. So the probability of x is less than 250. It's going to be equal to, now if we look at our graph here, 250 is probably there, and this is a length of 3, so we just want to multiply 3 by 1 on 8 times 1 on 8, so that's going to be 3 on 8, because it's a uniform distribution, which means it's a straight line. Go calculate the mean and standard deviations of the amount of milk in the bottles. The mean is just the halfway point, so we can just write 247 plus 255 all over 2. Put this in the calculator. 247 plus 255 divided by 2, 251. Now standard deviation, think about this for a second. It's going to be, okay, it's going to be an integral, square root of an integral, and we're going to go from 247 255 of x minus 251 squared. We're going to use the continuous random variable formulas for this essentially. And then since multiply this by the probability, and since that one is just 1 on 8, we just leave that as 1 on 8 dx. And I want to take the square root of that. And this will equal, oh god, time to put this in. 247 and 255, x minus 251 squared times 1 divided by 8 dx. My standard deviation is 2.3094. Let me make sure that this is, that the mean will work as well. So mean would equal 247. Wow, that is a horrid integral. Jesus Christ. 1 on 8 x dx. So let me just pull this here. I'm just doing this on my CAS right now. 1 on 8 x dx. Yeah, 251. Okay. That's all good. But since this is just a uniform distribution, I can just take the center point, because all of them have the same probability. A worker randomly selects a bottle from the conveyor belt one at a time. Determine the probability that it takes a selection of 15 bottles before 5 bottles containing less than the labeled amount have been selected. Jesus Christ, man. Okay. The probability that one is less than the labeled amount is 3 on 8. I'm going to say let x, because we're going to have a binomial distribution here, equal to 14, and the success rate is 0.0. It's 3 on 8, okay. 3 on 8. I want the required probability going to be equal. The probability that x is equal to before 5 bottles, so I want to select 4 of them first. I'll select 4 times 3 on 8, and that 3 on 8 is just that 5th one being less than the labeled amount. So here I'm also going to write binomial PDF, the value I want, and then our parameters, times 3 on 8. Now I put that in my CAS. I go to action discrete, distribution discrete by PDF 414, 3 divided by 8 times 3 divided by 8, 0.06751. Now I'm going to double check. This should be equal to 14 C4 times 3 on 8 to the power 4 times 5 on 8. Where's my pen? There's my pen. Power 10 times 3 on 8. If it's not, I'm not sure what I'm going to do if it's not. 3 divided by 8 to the power 4 times 5 divided by 8 to the power 10 times 3. Okay, it is the same. Excellent. Nice going. And that should be it. So, page 12. Question 17. Analyze examination scores, methods. Examination percent. Determine the following. The mean of x plus 5. Okay, well that's just going to be equal to 75 plus 5. And we equal to 80. The variance of 25 minus 2x. That's just going to be the coefficient in front of x squared times the variance of x. So this is going to be 4 times the standard deviation of x squared. So it's going to be 4 times 22 squared. And that's going to give me on my calculator 1936. Your exam should not have a variance of 1936, but that's alright. Anyways, double check everything to that, because variance is standard deviation squared. Yep, seems all good. Aim is to change the mean to 60 and the standard deviation to 15. Okay. This won't be so bad. Standard deviation of 15. So standard deviation is only affected by the coefficient in front of x. So then if I want 15, that's going to be equal to some a value. And since our standard deviation is 22, so it's 15 over 22. So a is going to be equal to 15 divided by 22. Gonna give me 0. What's the values? Okay, I'll put this decimal. 6818. And therefore, if I want to change the mean to 60, then this will be affected by A and B. So this is going to be 0.6818, and the mean right now is what, 75? 75 plus B. I'm going to put this in a solve in my calculator. 75 plus x. B is going to be 8.865. That was pretty easy. Page 13. The waiting times at a Perth airport departure have been found to be normally distributed. So wait for less than 55 minutes. 5% of the time was 30 minutes would be greater than 100 minutes. Standard deviation for waiting times. Alright. Easy enough. There's 2 ways we can do this. I will do this a longer. Actually, oh wait, no, I have to do this though. I can only think of one way to do this. Sorry, I was thinking that this was another type of question. Okay, first of all, I'm gonna do solve norm CDF. I'm gonna find out the k value for this 5% of the time, and it was less than 55. So I'm gonna go negative infinity to k 1 of 0. 0.05. I think you can also do this like an inverse left, and then you put in the percentage. It's going to give the same value, but it's alright. So solve continuous norm CDF. So solve norm CDF negative infinity to x of 1 of 0, 0.05. And this is k is negative 1.645. Oh, I probably could have got that. That's alright though. How much time? We have 15 minutes. And we only have like 5 more pages to go. Solve norm CDF. And then this one is going to be greater than 100 minutes, and that's 13. So I'm going to go k to infinity of 1 of 0 is equal to 0.13. So here, this value, x to infinity of 1 of 0 is equal to 0.13. K is 1.126. There's 3 decimal places, that's fine. Okay, now we can use our z-scores. So 55 minus that divided by that is going to be equal to that. And then 100 minus our mean. all over standard deviation is 1.126. Cast simultaneously. Math 1, simultaneous equations. 55 minus x over y is equal to negative 1.645. 100 minus x over y is equal to 1.126 x and y. So then our mean is going to be equal to 81.71. I'll do another decimal place, I guess. Doesn't hurt. 16.240. There we go. Next, determine the probability that the waiting time will be between 75 and 90 minutes. Well, it's only one mark. I won't even need to say that this is normal distribution. 75 to 90. Our standard deviation was 16.24. So I took 24. I'll put the 0 to show I'm doing 3 decimal places. And then 81.714. And then track that in my calculator. 16.24, 81.714, 0.3554. Next, page 14. The displacement, some rectilinear. By that, calculate the times that the particle is at rest. Oh god. Okay. Am I gonna expand this? Is that worth to expand? I don't think that's worth to expand. I'm just gonna say that v of t is equal to d dt x of t. So then cast. I'm just gonna do differentiate, and I'm just gonna put exactly what I see there. X minus 4 squared. I won't even put the minus 2 because I already know that's not gonna be on there. Oh, I get it. Okay. T minus 8 over 6. If at rest v of t is equal to 0, therefore 0 is equal to t minus 8 over 6. T must be equal to 8. Now, is that derivative correct? Let's see. Okay, I said I wasn't going to expand, and here I am expanding. Let's double check the calculator of all things. T squared over 4 plus 16 minus 4t. Should be a t. Oh wait, I see. 2t over 4 minus 4 1 over 3. And then I wanted to get as then I wanted the denominator as 6. Oh, because that would be times 2. 1 and 2. Wait. Oh wait. I see. So that becomes t on 4. T on 2. And then that becomes on 6 minus, and then I wanted that. Okay, it is the correct. It didn't look like that would be the derivative, so I just wanted to check. Displacement of the particle during the 5th second. Now these ones, once you get past the trickery of this, it's fine. The 5th second is from t equals 4 to t equals 5. So, and I want the displacement, which means I won't need to do absolute values. All I need to do is plug in the velocity function. So t minus 8 all over 6 dt equals, I'll just write displacement, equals, plug that in your calculator. This one's only 2 marks, so you know there's not going to be much to think about. Watch me get this wrong. I get negative 7 on 12 centimeters. Is it centimeters? Centimeters? And it's seconds. Okay, so I'll just write seconds here as well. The maximum speed of the particle and when this occurs. If max speed a of t equals 0, and then a here is just going to be 1 on 6. Wait a minute. Oh. Okay, I'll change my way I'm gonna answer this. V of t on cast graph. Cast graph. Okay. Let's check this out in the cast graph. X minus 8 on 6. It's going to be constantly growing, I'm pretty sure. I just want to double check. Oh wait, that's my boundaries too. Given that 0 less than or equal to x less than or equal to 10. Put the default boundaries. Graph that. And then, so the max. Yeah, it is just constantly going. Max. V. Oh wait, maximum speed. Speed can be negative or positive. Max V equals, let's see what it is. G solve. I want to solve for 1x is equal to 10. 1 on 3. Min V equals 0. So there was a little bit of thinking in this one. So negative 4 on 3. Therefore, max speed equals negative 4 on 3 centimeters a second. Oh, actually, sorry. Get rid of the negative. Speed doesn't have a direction. At t equals 0. The total distance traveled in the first 10 seconds. Now we get to use our absolute value. So distance is equal to 0 to 10 of absolute value of t minus 8 over 6 dt. Make sure that's a straight line. There we go. We can also just do this using some triangles, but this is a lot faster. So let's put this into my CAS calculator. 0 to 10, the absolute function of that. Dx, I get 17 on 3 centimeters. Oh, we're nearly there. 16, 17, 18, 19. Honestly, this one wasn't, I don't know, this hasn't been any particularly tough questions. A chocolate factory produces chocolates of which 80% are pink. Each box of chocolates contains exactly 30 pieces. I don't know. The number of pink chocolates in a single box also give the mean and standard deviation. Okay. So the mean would just be, how do I go with distribution? Never mind. Now I'm thinking, okay, I definitely know that the mean. I'm a bit confused. Does it just want me to say it's a normal distribution? Or is it, does it want me to say it's a binomial distribution? Because it's either pink or it's not, right? Okay, so binomial distribution, where I have let x is equal to binomial distribution, and I'm going to have 30 pieces, and my success rate is 0.8. Okay, I knew this was a binomial. Well, I started to understand it was a binomial because it's exactly 30, and for normal distribution you want more than 30, and also n of p, so 30 times 0.8 is 24, which is fine, above 10, but 1 minus p times n, so it'd be 0.2 times 30 is only 6, and that's less than 10, so it's not going to be a normal distribution, so it has to be a binomial distribution. It also makes sense because the box of chocolates can either be pink or not, so that makes a lot of sense. Now the mean is just going to be n of p, which is going to be 24. Standard deviation is just going to be np 1 minus p square root. So that's going to be 30 times 0.8 times 0.2 calculator. Let's see. 2 square root of 30 over 5. That makes no sense to any sensible human beings. 2.191. There we go. Determine the probability to 3 decimal places there are at least 27 pink chocolates in a randomly selected box. So then I want the probability that x is at least, okay, greater than or equal to 27. So then this is going to be a binomial CDF because cumulative. So 27 to 30, and put in my parameters 0.8. Now I can't speak. Now I'll put this into my calculator. So binomial CDF 27 to 30 of 30 over 0.8 is 0.1227. Alright, 4 decimal places, no rounding. Yep. Quality control collects sample size of 20 boxes and count the number of trips. Interval proportion in a sample 20 boxes, assumption 80%. Okay, so I'm gonna know that P is going to be equal to 0. Okay, yeah, because the population is gonna have chocolate factory. Yeah, so everything the factory makes. So this is gonna be the population proportion, not the sample proportion. And then for 95% confidence, K is equal to 1.96. Actually no, I can just put this on a cat. Okay, I'm just gonna say CAS stats. Okay, I'm gonna go menu statistics because it's only 2 marks. I'm not gonna do all of that. Calculation interval. One sample z int on a list. Nope, sorry, not list. Variable. Confidence level 0.95. Standard deviation. No, wait. One prop z interval. Okay, 0.95 x. It's gonna be 0. Proportion of pink chocolates in a sample of 20 boxes. The proportion is gonna be 20%. And the number of boxes I want. Sample of 20 boxes. Stat calculation. Did I choose like the wrong thing? One sample led int variable. I don't understand deviation. Okay, let's try to do this anyway then. Margin of error is going to be equal to 1.96 square root of 0.8 times 0.2 over 20 boxes. Each box of chocolate contains 30 pieces. I think I'm doing good. I'm gonna put that on my calculator, see what I get. 0.8 times 0.2 divided by 20. 0.1753. Therefore, so 0.8 minus 0.1753. 0.6247 less than or equal to P. I'm not entirely confident in this. 0.953. I'm not sure if this is what it's asking me to do. He wants the proportion of pink chocolates in a sample of 20 boxes. Sample. Oh, oh shit. I think I get it. Okay. Okay, I'm gonna change this. 95%. Okay, I want 20 boxes. And in each box there's 30 chocolates. So my population is going to be 600. Which makes sense because it has to be greater than 30. So I'm going to change this to, in my calculator, to be 600. And this is 0.03200. Therefore, 0.768 less than or equal to P less than or equal to 0.832. I think this makes more sense. Proportion of pink chocolates in a sample of 20 boxes. So you're not looking at per box, you're looking at the whole sample, 20 boxes of how many pink chocolates you have. That makes sense. Okay. I'll just add a little note here. N is equal to 20 times 30 equals 600. 600. Okay. 17. We're nearly there, guys. Quality control collects 3 samples and determines a 95% each time. Determine that only one of these intervals will not contain the true value. Only one of these intervals. Okay, so the probability that it doesn't contain. So let's just do. If I define x as a. Yeah, I have. Okay, let's just do. Let y be a binomial distribution, and we're gonna do 3 because we're making 3. And we're gonna do 0.05, and then I want the probability that y is equal to 1 because this distribution is describing the probability of how many samples are not gonna contain the 0.8. So then this is going to be the binomial. I'm not going to write it again because I already shown you guys how to do it. So binomial PDF of 1 of 3 of 0.05. This is 1.354. Using 90% range in which the expected number of pink chocolates in a sample 20 boxes would lie. So then it's going to be 600 times proportion. Is that a nice way to write it? How many marks is this? 2. Okay, I'm not gonna write like z equals 600 or whatever. Okay, so where is the proportion? 0.768 times 600. It's gonna be about 460.8. That's gonna equal to expected number of pink chocolates. I'm gonna say let n equal number of pink chocolates. And then what was the upper? 0.832. 832 times 600. 499.2. There we go. Quality control counted the number of pink chocolates in 5 samples before. Decide which values lie outside. Okay, so that's a 90% confidence interval. So we just have to find which values. Sample 1 is below, and sample 5 is above, and that is it. Sample 1 and 2. Wait, why does one have to justify? How are we going to justify? We're just going to say it lies outside. Wait, I dropped sample and 2, and that's completely wrong. Sample 1 and 5. Sample 1 lies below 95 CI. And then sample 5 lies above 95% CI. And I'll just say in This is F, must be E. E. Okay. Next page, 18. I don't know what it means by justify. Because if it's outside, it's outside. Does it want me to calculate the p hat of all of them? Surely not, because this is exactly expected number of pink chocolates. Okay, yeah, no, I'm not doing that. Too much work. Okay, I might do that. I might come back. How much time we got? We got half an hour. We're gonna got one more question left. We fine. Okay, one has 12 kilometers away. The shoreline opposite point X is seen in the diagram. A long break is placed on the shoreline. Night light seen Y equals placement of the wall. Theta is rotating light. 3 rotations per minute. 2 pi times 3. This is like this is really like what do you call it? Specialists? Related rates. I think this is related rates problem. Yeah, I think it's related rates problem. Alright, dy d theta. Okay, well I just think this is gonna be what? Yeah, okay, so y equals that's gonna be what, 12. Let's do this. Let's do the full working out. So tan of theta, opposite over adjacent, y with 12. So y equals 12 tan of theta. Then if I want dy d theta, that's going to be equal to, they don't need to show out the working. Is this in a formula sheet? If it's in a formula sheet, I feel like I don't have to show that tan of theta will be d theta, tan of theta equals cos, 1 over cosine squared of theta. Let me pull out my formula sheet real quick. Oh yeah, I've been doing this without like my own notes page. I should have had the formula sheet with me because this is like a given. Yikes, it doesn't show. So what if I just say cast and then it's 12 cosine squared of theta. 12 tangent of x. X plus 1. Oh god. I don't want to write this. I have to show it. I don't want to show it. Fine, whatever. Okay, so y equals 12. I'm just what I'm saying is that it's 3 marks. I have a feeling they want me to show how to differentiate tan of theta. That's essentially what I'm thinking of. Because otherwise, I feel like this would be a 2-mark question. Okay, why is that? And then dy d theta. 12. Okay, derivative of the top is cosine of theta times cosine of theta. Derivative of the bottom is negative sine of theta times sine of theta. All over cosine squared of theta. Oof, my mic getting close. My mouth getting close to the mic. Apologize. So then that's 12 cosine squared of theta plus sine squared of theta over cosine squared of theta is equal to 12 over 1 over cosine squared of theta. It's equal to, yeah, okay, whatever, else we write it. Cosine squared of theta. There you go, there's your mess. Determine the velocity in kilometers per minute of the light well when the light is 5 kilometers north of point X. Hint, dy dt is equal to dy d theta dt. Okay, well then I know that dy dt, thank you very much, is equal to dy d theta is 12 cosine squared of theta. Cosine squared of theta, and then the theta dt is 6 pi. 6 pi. Yeah, this is just like a bit of a dumbed down related rates rule or question. So when the light is 5 kilometers north of point X, if this is 5, wait, y is 5, then theta, so wait, 5 is north of point x is there, okay, then if y equals 5, then what did I say, y is equal to 5 is equal to 12 tan of theta. Put this in my cast. What is that? Ew, okay, 0.3948 radians. Therefore, dy dt equal to 12 over cosine square of 0.3948. Yep, times 6 pi. Let's pull that fraction all the way across. Okay, this is our final calculation, guys. 0.3948 squared, 6 pi. 265.47. Okay, let me see. Is there like some conversion I have to do? Kilometers per minute. What am I working in? I'm working in kilometers, and it's given per minute. So there's no conversions I have to do. Nice. Wow, that is a very fast light. Okie dokie. And I believe that's the exam done. So I will come back. I will, we have some time left, but I mean, I'm not gonna, do I want to go through all of this? I don't want to go through all this. Maybe another time. I have to go head out somewhere in a little bit, so I think I'll just mark it now, and then I'll come back. I'm gonna cut right now. I'll come back. I'll discuss any errors we made, and then we will be done with this walkthrough. So yeah, goodbye. Well, I'm gonna see you in a second. Oh my god, this is so. Yeah. Okay. Bye. Welcome back, everyone. I have just marked our exam. You're gonna have to believe me, but I did get full marks in calculator 3, and I lost 8 marks in calculator assumed. So we'll be going through, having a look at where our errors were. I'm gonna flick through everything. Obviously, if I circled it, that means we got the full marks for that question. This is the first question we lost some marks on. We lost marks here because they wanted us to use the confidence intervals to compare between the different surveys and the confidence interval we had before. I don't like this because sometimes they want us to use confidence intervals, and sometimes they want us to just compare the p-hat values like what I did. But yeah, unfortunately, all the marks for this were related to the intervals. You got 1 mark for determining intervals for all the 3 surveys on your cast. Got another one for comparing the interval to the one in part A, and you got the last mark for using these intervals to create an argument. So I assume they said that interval survey 2 does not overlap with the interval in A. However, I assume that you could also talk about survey 3 because there's only a little overlap between the intervals. Anyway, marks. Oh yeah, here was an alternative solution. You could have just found A and Z and AH in index form and then divided them like that to find your ratio. You also didn't need to evaluate it to 126. You could just leave it as 10 to the power of 2.1. Here I needed to put an open circle at the when x equals 0, because over here I even wrote it down. I wrote x is greater than 0. Obviously you can't have it at 0, so I lost a mark there. Going through. Oh yeah, I thought this was a bit silly. One of the points you had to say, or one of the 2 other points. Okay, so I got 1 mark for saying that it's peak at whatever or centered around there. Another option you could have said is that it takes the shape of a binomial distribution, or that it approaches the shape of a normal distribution for large n. I mean, we have a large N, so it already is. It should. I wrote this, but I didn't say for large N, which is a bit. I don't know, man. Like we already have a large N. It's greater than 30. It should take the shape of a normal distribution graph. But I decided to not give myself the point there, because I didn't include for large N. And then also binomial distribution and normal distribution, I'm pretty sure they look the same. I mean, like, I checked online because I was like, I was a bit confused. But yeah, moving along. Yeah, 4 marks, okay. Here, got the mark. I cannot believe I messed this up. I remember doing this question before when we had the wrong values in over here, 3 and 4. And then I changed it to the right values, and then I didn't update it in the second part, which is not good. It's funny because if I didn't change these, I probably could have just got follow through for this question, and I got 2 marks here. I just lost the 1 mark, but instead I lost 2 marks and gained 1 mark, so it's a net loss. So a bit unfortunate, but yeah, couldn't give myself any mark. Got 1 mark for using the correct values from the table, and another mark for the correct probability. I decided, obviously, I mean, these values are not the same as these, so yeah, couldn't even guilt trip myself into giving me that mark. But otherwise, that was all. The rest of that was fine. This was all done fine. All done fine. Is there even another mark loss? I'm sure there was. There it is. Yes, I seem to not have read I have to determine the probability to 3 decimal places. Even though in every exam ever, probability is down to 4. For some reason, they want us to round to 3 decimal places here, which is a bit annoying, but I don't know. I guess just read better then. I believe that was it though. Everything else here we did correctly, which is a very good sign. So our final percentage, I already showed you at the start, but it was 94.9%, which is it's decent, I guess. I would like this to be 95, 96 or above. But yeah, my average for methods right now after my mock, I got 98 on my mock, which was damn impressive. I was really happy with that. And my average right now for the whole my school grade is 96 point something, so it rounds down to 96. So yeah, I would like to get this a little bit higher up, but that's alright. I think there was some BS like marks in this marking key and this answer key, but you know, it is what it is. So yeah, that's the end of this exam. Next exam will be my chemistry exam that I'll do. That'll be a long one because I missed a section in this exam, so I missed out 15 minutes there. Yeah, chem will be 3 hours plus marking, and I'm sure there's going to be a lot of marking in chem. So yeah, goodbye.